The 8th step to graphing a rational function is to take all the information that you've received in steps 1 through 7 and finally graph that function. In the first step, we found out that our domain was all real numbers except for -3 and -2. In step 2, we found out that the x-intercept was the ordered pair 1, 0. In step 3, we found the y-intercept to be the ordered pair 0, -1/2. In step 4, we found out there should be a hole at x equals -3. In step 5, we found out there should be a vertical asymptote at x equals -2. And I've written out to the side of this, make sure you graph that using a dotted line. And then in step 6, we found out there's a horizontal asymptote at y equals 1. Also use a dotted line there. And then finally, we found out that there was no slant asymptote. So what I'll do is I'll start by plotting any type of points that I know to be on my graph. We see here that my numbers are relatively small, so let's do our scaling just to 3. So 1, 2, 3, each direction. I think that will give me a good enough idea. We can always change that later if we find out that doesn't work. We have an ordered pair 1, 0. So let's plot that. We have an ordered pair 0 and -1/2. Plot that. Okay, that's the only ordered pairs that we know for sure are on my graph. Now, let's go skip the whole, we're going to wait kind of on that. We have a vertical asymptote at x is equal to -2. Let's go ahead and do that. Because it's x equals -2, it would be a vertical line. We want to make sure it's dotted. And I'll go ahead and label that so we know for sure that that's our vertical asymptote. We have a horizontal asymptote at y equals 1. So there we would draw a dotted line that's horizontal through y is equal to 1. And we see that it intersects the other vertical asymptote. And then from here, believe it or not, we have enough information for us to be able to graph our function. We know that there is only one x-intercept and only one y-intercept. We see that those occur kind of on the right-hand side of my graph. The graph must go through those ordered pairs and at the same time be drawn close to our asymptotes. If we draw, I'm going to say my graph going through these points here, we see that the graph must be drawn up towards that horizontal asymptote of y equals 1. Going the other way, we have to be drawn towards that vertical asymptote of x equals -2. So the graph on this right-hand side is going to be somewhat curved and be drawn towards those asymptotes. Now, we cannot have a graph in this region, and the reason being is that we know we don't have any more x-intercepts, and so if we had a graph in this lower left region, then we would be forced to at some point cross that axis because we'd need to be drawn towards this asymptote. So there cannot be a graph down in that portion. That being the case, then we know that the graph on the left-hand side is up in the upper portion. And what happens here is it's forced to have a C shape because of the way that it must be drawn towards the asymptotes. We know for sure that there's a graph over there because we see that our domain includes those values basically in this region. And so we know that that particular part has got to have a graph within it. We know that we cannot be up here because if we were up there, then our graph would fail to be a function because of vertical line test. If we had something up here, this vertical line would cross through the graph here and then also go down below and cross through the part of the graph we already have drawn. So we can't have a graph there. Now remember this one thing that we left out. We said there's got to be a hole at x equals -3. Well, do we see we have this partial C-shaped graph up here? We need to come back and we actually need to erase part of that, and we need to make sure that there is a hole above x equals to 3. So this little C shape that I will have will contain a hole above wherever that -3 is. Okay? Now this is my graph of my original function that was back here. You can check this graph on your graphing calculator. If you do that, when you're checking on your graphing calculator, just make sure that you use parentheses around the numerator and the denominator of the problem. The one thing about checking this on your graphing calculator is that this hole is not going to show up on your graphing calculator. The calculator, I'm going to say, is too large to actually be able to show you that hole, or not good enough to be able to show you that hole. So that's something that you are able to do that the graphing calculator doesn't necessarily recognize unless you really zoom in where -3 is. Generally speaking, rational functions are going to have odd and interesting looking graphs. It's very normal to have a graph that looks like this. When you have a horizontal asymptote and a vertical asymptote, you generally have a graph on one side and a graph on the other. That doesn't always have to happen, but in this case it was forced to happen. But kind of long story short, you're going to have weird and interesting looking graphs when you're graphing rational functions because of the asymptotes.